Hey guys, my name is Arun Tyagi, and let's continue our journey where we are discussing high level designs. So, today I'm going to discuss one of the most complex system design we can think of, which is Google Maps. Let's start with the requirement. I'm sure all of us are basically users of Google Map. We use it in our daily lives. So mostly we know the functional requirement, and we are basically just creating a subset of it. So we will target some requirement. Google Maps is a very rich application. So we'll take some main requirements of it, and we'll try to make a system design for it. So the main requirement, the obvious one, is that if we give a source and destination, where source normally is where we are right now and destination is where we want to go, in that case the system should be able to find the best possible path for us. Then to do that, obviously we are not going to send lat long of both the source and the destination. So system should be able to get the location, our current location, and also if we give some text address, the system should be able to find the exact lat long of that text address. So that is another functional requirement for the app. And then third is, once we have the route from source to destination, then the system should give us the navigation, that go straight, take left, like we see in the app. So it should be able to give us the entire navigation from source to destination. Now let's suppose we will focus on only these functional requirement. Let's see what non-functional requirement we have to think of. So first is this system should be highly available. By highly available, I mean, think of, obviously when such a big system is there will be some failures in different regions, or you can say in some network. So even when some of the servers, some of the databases, or some of the regions network will be down, at that time also the system should be available. So that way we will make sure that whatever computation and storage we are using, there should always be failover available for that. Then in terms of scalability, we know that there are very high usage of something like Google Maps, and by scalability what we mean here is like right now maybe only 100 users are using it. Now suddenly thousands of users, or you can say 100,000 users suddenly using it, system should be able to cope up with that. It's not like it stopped basically serving if there are suddenly a spike on the ingress. And obviously there will always be upper limit to that we are designing for, maybe 1 billion. We will talk about some numbers in next section. Next is have to be a very low latency. Especially think of navigations, right? So you have the route you are going, and if it latency in telling you that you have to take left will be higher, then basically you will miss that route. So latency have to be very minimal, because you are using it on the go, right? And the last is you can think of the estimates or the route. Normally it gives you the route with the time, that from source to destination it will take you 4 hours. So that cannot be exact, but this should be near to the ideal the real number, right? It cannot be like it says 4 hours but today it took 6 hours, right? Or tomorrow it is just taking 2 hours, right? Means it should not be like for one user it is taking lesser, and for another user it is taking more. So when a user is inquiring for that, your estimates have to be accurate there. Now when we have to design what actually the difficulty is in that, that we have to think of first, that where should we focus while we are designing this. First is because we are talking about distance and route finding, shortest distance basically between 2 points, then I'm sure we are aware of that there are a lot of algorithms which are available to find shortest distance between two given nodes in a graph, right? But having said that, then what is the difficulty we are having here is, if we are talking about the real world, and real world what we are having is that's the scale, that the points in this graph, where the graph is nothing but the entire world, the entire earth. So the points from from where you can ask go from this to this in that entire graph, there can be billions of nodes, and same with the edges, right? So that you have to think of, that obviously you cannot directly run algorithm on it, that if a point 1 and point 2 is given, just run a Dijkstra and return the output, right? That is not possible. You will not have enough resources in terms of memory, in terms of you can say the computation power, so you will never be able to compute it on the go, I'm saying. Second is we have to think of, when you are talking about the accuracy in the estimations which you are giving, that it will take 15 minutes or 2 hours from point A to point B, we also have to think of that there are variables like live traffic, road conditions, some accidents, some event is going on somewhere, so there might be rush in that particular place. So when we are giving estimations, so that also we have to think of, that how we will accommodate our accommodate these things in our design. So before we jump on any design, let's talk about some numbers, some estimations, that when we are designing, what kind of ingress we are thinking of. It cannot be like one design can work for all the numbers. And don't be overwhelmed with this math, because this is very easy, and this is something, if you do it once, you will be able to apply the same in almost every system design you will practice. So let's think of that we are saying that we are having monthly 1 billion users. So this is an estimation I'm taking, that while when I am designing this service, I am thinking of these many users. I'm assuming Google real number will be near to that, but not necessarily exact. So I'm not talking about what is the number for Google. What I'm saying is, when I am designing this, what is my target. If I'm having 1 billion monthly active users, so then I can think of I will be having something somewhere around 32 million daily active users, right? And intentionally I took a big number here, so that when I'm designing, I'm basically thinking of that how to design all the service when my ingress can be this high in a day. I'm talking about, right? 32 million is a very big number, right? Now let's think of that how many servers we actually need to handle this much of ingress, right? So for that, I said that 32 million is my total, the ingress will be in a day. Then I'm saying that 8,000 requests one server can handle. Now how I came to this number is something, basically I think I should create a separate learning for it, a separate video for it. But if you think of normally we have two kinds of request. One is which requires CPU to do anything, means heavy usage of CPU, and we call them CPU bound requests. Another one is the requests which are memory bound, where you need to where you require a lot of memory. right? So normally it is like on CPU you can only process some 60 requests per second, right? And for which are the requests which are memory bound, basically you can handle up to I think 16,000 requests per second. This is basically, you can say, so we can come to this number and we can talk in details about it in a separate video. But if I just took half of this and half of this, and basically I'm imagining, you know, some of the requests are this and some of the requests are this, then my maximum will be basically half of this, which is 8,000. So if I'm taking 8,000, considering my, though these are HTTP requests, and normally web HTTP requests are very light if you are serving everything from your in memory. Means if you ignore for the time being that you have to request further services, you have to request from DB and there will be latency and all. So normally these are very light. That way your one server will be able to serve 8,000 requests. And if one server can handle 8,000, that means to handle 32 million, you need 4,000 servers. And a system with 4,000 server is actually very huge. Now let's just estimate that how much how much bandwidth is basically required, when ingress is there, and obviously you will return some response to those ingresses. So think of basically we have our daily active users, and let's suppose my one user, this is daily active user, but one user can send multiple requests. So I'm just taking a worst case that, you know, one user can send maximum 50 requests in a day. So I'm taking this as an upper bound. Normally we do not send this much to Google Maps, but this is, I'm taking a worst case scenario. If every user will send 50 requests every day, right? In 50 requests basically per second, sorry, every day, then my per second request will be just divided by, you know, how many seconds are there in the day, and then ultimately we will get 18,000 requests per second will be my ingress. So I have to handle 18k requests per second. Now if I see what user is sending is some text and all, so we can actually count how many bytes will be there, right? On basis of how many maximum number of characters will be there. So I took an approximation of 200 bytes will be the size of my maximum size of my the input which is coming towards my server. If 18k are there, then 30 MB per second is good enough to handle the 18,000 requests per second. If I have to talk about output, now in output sometimes, you know, we send images, and especially in navigation we might send a long output to our user, right? So here I am considering that it will be combination of visual, where I'm talking about the images, and text, right? So text is obviously very light, but your image can be heavy, right? So if I am saying that 2 MB of data will be returned in every response from the server, then if I just simply do this multiplication, then 300 GB per second is going to be my output bandwidth which is required from these servers. Okay, so these are some just back of envelope estimation which we say. So the main thing to think about is, you know, that think of that, you know, your server can handle 8,000 requests, and in obviously this number can never be accurate. It took these many years for industries, you know, big companies to come up with this, that how many requests our server can handle. This is still not very accurate, because ultimately in real life, when I design my systems, the max I can think of a 5k number, because when I'm having regional load balancer, global load balancer, and my server is calling the backend, there are going to be more latencies. So my server will never be able to respond to a global my regional load balancer to that much, and basically same way. So these numbers keep on decreasing in the real life scenarios. But when you are designing, you can think of that if your one system can serve 8K, then think of how many servers you actually need, right? Okay, now let's move to the next section. So now what I'm doing is I just created a high level design. Right now, basically I don't want to go into the complexity first. What I want to think of is, think of that you have all the services already designed for you, and if you have all the services separate, small services for small problems already designed, how my high level entire system will look like with that. So I will discuss that first, and then we will go deeper into these services so that it looks manageable. So think of this is basically very similar system which we created in other system design videos also. So think of basically you are having a user, you are having your users which are sending request via load balancer. Then you are having different services. One is for finding the location, finding your where you are, the area around that lat long, the location. Then one is the navigator service, which is responsible for when you are sending that where I am right now and where I am going, it is giving you the direction that go here and go there. It's like the entire list of what the path you should follow. Then if you already have a service which is responsible for to give you the output that for a given source and destination, this is the route, right? So this guy is responsible for that, and assuming that this guy is capable of giving you the exact ETA, and this guy is also considering that what is the live traffic, what is the road condition right now. Different roads will be there in between your source to destination. If that service is also there, so this service will help us with that. And now this service, because this map service is doing too much, this is basically taking help of one more service which is doing the heavy job. Let's call it a graph processing service. By graph processing I mean is, if my entire world is a graph, then this guy is taking inputs from multiple places and storing the data in a database as such that it can query very fast that if I am going from A to B, what is my path, and if you what is the path, what is the ETA, all those things are stored here directly. How we are doing it, we will discuss it later, but let's think of that this guy is doing it somehow. Then this graph service is also having inputs from you can think of third party data provider services. For example, we let's suppose we hand over some endpoints to some third party. That third party can be government agencies, traffic police, and our vendors itself, which are feeding the live data that right now maybe some event is going on at this place, so this particular edge or this particular road is busy or blocked. That kind of data is continuously coming, you can say, to graph service, and this graph service is making sure to update that info into the database. Same way we are from our think of from our Kafka, we are getting the live info of as you see that navigator service is feeding the live data to this, that basically how user is going, how much time it really took, right, to that user. So having that input with us, we will keep updating our data using all that inputs also. That we said that this will take 45 minutes, but almost every user is actually taking 90 minutes. Something is there which we are not aware of. Maybe our third party, data providers didn't have that info. So we may use that live data info to update that right now this is what happening there. And to support our graph processing service, we also need another service. Think of let's call it a segment service, and we'll discuss this also in detail, what does segments means. But think of that what this guy is responsible for is dividing the entire world into small segments. And when you are basically giving that what is a segment for source and destination, and basically for these segments give me the route, this guy will be able to give you the segment info, right? And this is obviously having the data, segment data, so it needs a separate you can say database to store all those segment information for it. So if you have all these services, all these 4-5 services optimally working, then that is all you need to basically serve these functional requirements, which is to find your location, right, which is basically to find a route between source and destination, and then finally to navigate user when it is going on that particular route, right? Now if I talk about all three scenarios here itself, before I jump into the details of these services. So first is basically user will give, for destination it will give a text input, and when it is typing we can use our autocomplete, and for that we can leverage our Elasticsearch basically to give that text address when they are typing, right? And ultimately our combination of these two, Elasticsearch and our location finder service, it will convert that text and the input from the app to latitude and longitude of that particular point, of that particular address. And to find the current location, we will use things like, obviously GPS is the main source of having the lat long. Then we can also use the Wi-Fi to get the location. We can also use the cellular, your phone network, to find the location, right? So these can be other things which we can use, so that app itself can send that where I am right now, right? So location finding will be done via this. Once you have the location of your say of your source and destination, what you need to do is we need to send this to our map service. What that map services will do is this service is actually very dumb. What it will say is, it will say to graph processing service that I am having an S, I am having a D, tell me the best route for this at this particular time, right now. So this graph processing service will do nothing, but it will simply check in the DB that there should be multiple routes already stored in our database with the ETA and all, and it already considered live, because as it is receiving the latest information continuously, you can say streaming of inputs, it is updating this data every basically on live basis. So it will consider all those paths and it will return multiple paths to this map service, and that will be returned to our client side, and client side will render it and it will show those options. That best as per me is this, but there are other two options which are like, one is 9 minutes slower, one is 5 minutes slower, and like that. And also if we have info of how much money it will require to go there, toll and all, right? And a graph, and for segments, let's discuss it later, because right now I haven't established that understanding of segments, that how I'm thinking this services. Just think of that one service is there which will help the graph service itself to find something complicated. Okay, that's it. Now before I move forward, one more thing I just want to highlight here is this load balancer is a symbolic load balancer. Whenever we talk about, we have services and a load balancer in front, in real world what you will have is, let's suppose that service is obviously it will be a distributed service, right? By distributed we mean is that service will be available in different regions, and even in one region there will be multiple instances of it. So if you think of for this particular service, we will have let's say AKS in East US, right? And that is having here, you can say 3 instances only. Then basically in inside AKS basically you have 3 different pods, right? And 3 different pods, and in every pod you have one instance of this particular area location finder service running, right? So 3 are running here. Then you will have let's say 5 are running in central US, because maybe central US is having more ingress. So another instance of same thing is here. So 5 pods are there, and in every pod there is one instance of area finding service installed. In front of this AKS you will have something called a regional load balancer, which is doing nothing but distributing the load within these pods. Okay, so this is doing that. So that way, even if one pod will go down in that region itself, you are having different pods to share that load, and all of them are functional independently. So they are not dependent on each other in functionality. So even if one is there, that will do the same job as any other will do. It's just that they are doing the load sharing. Same way here will be a load balancer, right, in front of the second region, and same way for every instance, wherever you will create whatever number of instances, there will be load balancer. And in one region also you can have 2 different clusters, right? AKS1 in central US and maybe AKS2 also in central US, another cluster, and which will have a regional load balancer again in front of this, right? And if a load balancer is good enough to handle, let's say total 18 instances are there, 5 were there and some are here, then there can be one regional load balancer which is basically sharing distributing the load among these clusters, right? In front of these load balancer there will be global load balancer. So this global load balancer can be you can say your route mapping, where on basis of that DNS mapping, I would say that if a request is coming from this region, I just need to return the IP of this regional load balancer, right? So every request need not to come to this. It is just like when you're coming for first time, you will come and it will return the IP of this, then every request is going to this regional load balancer from that particular area or from that particular user, because it got cached. And when you do not have cache, then you go again to this global load balancer to get the IP of the regional load balancer. Or there can be a real global load balancer, which is like every time you are hitting the request to this, and this guy is redirecting you to one of the regional load balancer. So every request is going via this. So there can be these options. So I just wanted to highlight that it is not like there is just this one load balancer and which is distributing among these. Okay, so now to understand those services which we just discussed, let's establish that understanding via some examples. Right now, there are different there will be different scenarios that when we are requesting for a path between a source and destination. So my first scenario can be okay, and before I go into scenario, let's think of this is my entire this is nothing but the earth, right? And what I did is I just divided it into some segments. So if this is my land area, so I just divided it into small segments, right? And every segment will have points. Points means think of that these are the points which you are requesting that I want to go from this to this, right? And a point is always defined by your on a graph. It is defined via your two axes, basically your latitude and longitude, right? If my map is divided into segments, and now there will be billions of segments also, right? And okay, so for now we can ignore the complexity of that. Maybe in a tensed area there will be thousands of segments even for one city, and in a area which is not very dense, there might be only 2 segments for the similar area in terms of kilometer, in terms of the distance, right? So we can divide unequal physical length into different numbers of segments. But if we have segments like this, then the requirements can be like I am basically standing here right now and I want to go till this point. When I'm doing this kind of a request that I want to go, let's call it a S and let's call it a D, right? Then if I have to go from here to here, I will request to my server that this is the lat long of this, this is the lat long of this, and obviously I used my area and location finding service to get the lat longs. Then give me the route. Before it will give you the route, what it will do is it will identify the segment for S, it will identify the segment for D, right? If the segment is same, that means you are actually having very less number of nodes in that and very less number of edges. Okay, what you can do is you can directly run a Dijkstra algorithm to find the shortest distance, because now you are talking about maximum of 10 to 12 number of vertices and edges, right? Even running this Dijkstra algorithm we will not do when user is asking for asking for route between S and D. What we will do is offline, upfront, when we are going live with Google service, beforehand we will calculate it and we will store it into a DB like this. So for every point within that segment, we'll create a table like this, that from A to D I am having 11 kilometers, and obviously there cannot be, this need not to be a straight line, right? This is just a road. It is just you can say representation of an edge here, right? That from A to D you have 11 kilometers, and ETA right now is 15. You will store that ETA right now, whatever the ETA is for you. Right now you may not be having any traffic information, right? So maybe basically you just you found it via traveling, the real data, that what it took from there to there, and maybe you just took an approximation on basis of the kilometers distance between that, and maybe you are having the road basically you can say how the road is right now. So using different things, you can think of a ETA in starting, which you are feeding, which is like when there is no traffic, how much time it will take, and you will store the path also. So if you did this pre-processing already, and basically you created this kind of data into your database for each segment, then if somebody is querying for any point to any point, think of in this graph within same segment, then it is just a straightforward call for you. You will directly go into the database, you know your source, you know your destination, and you will simply return these information. And if there are multiple routes, think of that there will be 2-3 entries, you will return all of them, and then another service will do ordering, which will do ordering and sorting and all those filtration part, that will do, and simply return it to the client. So this is very straightforward for you. It is just like querying from DB and serving to your client. Now here we didn't even think of about live traffic, road condition, weather, accidents or not accidents on that particular route, or other live inputs, because we are trusting that our graph processing service is keep on updating this. So we are considering when I'm reading this for my query, the data is very accurate in this one, hence I will serve it to my customer. Now think of the second scenario. My second scenario is when my source, hope this is clear. Yep. When my source, say basically I'm going from a point which is here, right, to a point which is here in S3, and they are far away, right? So if I need to go from here to here, then how to find? So in one segment I was saying that we already ran the extra algorithm and we stored it and we served it, and also even in runtime we can do that because it will not be very slow. But what to do in this scenario, right? So first of all, we just need to establish one understanding first. Now when we are talking about inter-segment path, then now let's see, this is S2, the segment 2. In this, just focus on the exit points of this segment. Here, for example, I took 4 exit points, that from here you can enter or exit, from here you can enter or exit, and in real life maybe this is only exit, maybe this is just a one way, right? So that information also we will save. Here also we have another exit point, and here also we have another exit point. And these exit points are shared between S5 and S2 here, right? So shared between the neighbor segments, right? So just focus on exit points now. So if we focus on exit points, so from here, if I'm in segment 1, from segment 1 I just need to think of how to exit from here, right? There can be multiple exit points. How to exit from here and enter into S2, then how to exit from S2 and enter into S3, right? Maybe here will be another point, right? Then from S3 how to reach to this, because now they are in same segment. So how to reach till here. Okay, so now my number of vertices, because I will ignore all the points which are inside a segment, I am ignoring those. So again, My number of vertices is something I want to reduce so that I can run my algorithm again on less number of vertex and less number of edges. Okay, now how we can do it? Let's try to see that solution. So there is an basically standard, you can say a well-defined way of doing this. So let's think of that I have to go from this S to this D. What we will do is, first let's find out, so now even if I consider all the exit points of all the segments, then also on a real graph there will be billions of vertices, right? Because there are so many segments in entire world, and I will not be able to run any algorithm on that. So what I will do is, first I have to reduce number of segments, and then I will consider the vertex, these exit points, as my vertex into the graph where I can run that algorithm. Okay, so what we do is, first we find out what is the aerial distance between S and D, and to do aerial distance there is basically a geometrical formula for that, right? So first we will find out what is the aerial distance between this and this. Let's suppose that aerial distance is 10 kilometer, right, or 20 kilometer, whatever. If I'm having that distance, what I will do is, I will take, using my the service which we had is area finding, right? So first I will find the segment of S, I will find segment of D, maybe I got S1000, right? This is S1000, and for D I got my segment 198. These are just for example, I'm taking that 198 is the ID of this segment and 1000 is the ID of this segment. Then what I need to do is, I will find all neighbor segments of S1000 which are within the range of 10 kilometers of this. So what I will get is neighbors like this here, and then in this circle, right, this circle will be bigger, right? So even it will be something like this, right? So in this circle, give me list of all segments. Same thing I will do for D, that from here if I draw a circle of 10 kilometer, which will be like this, right, give me all the segments. So I will receive a list of segments for this and segments for this. Now I will consider all those segments. From all those segments, what I will get? I will get exit points of all those segments. So then I will have list of exit points like this, 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 and some are here, some are, there, like that. So I will have a list of segment points, exit points, and also obviously the edges which are connecting those exit points. That list is now a graph for me. So now that entire world is eliminated. I am having that limited number of vertex, limited number of edges, and I will run a Dijkstra algorithm on that. So that way I will be able to have options, multiple routes from here to here, right? And again, in same fashion what I did earlier, I will store that info in my segment, basically that from S2, from S1000 to S198, the distance is, you can say, because the road distance might be you can say 15 kilometer, and path is this, that go from S1000 to the neighbor, to the next neighbor, to the next neighbor, and you will reach to S198. This is one route. You might get another route that for the same one segment 1000 and segment 198, basically you are having a distance of say 20 kilometer, but this guy is only taking 30 minutes, and route is this, go from here, this segment to this segment, something like this. So ultimately we will store this information also into database, right? So now we need to just return that from this segment to this segment, these are my you can say the outputs. This is my result, these are my options. Now one thing which we haven't discussed is, and I will go back to the previous diagram for that. Yeah, let's think of this one. Because I was talking about, you know, going from segment to segment, and like here we might be at this point, and maybe the real vertices here are this and this, right, which we considered when we created that result and saved into our DB. We might consider that A is one point, D is another point here, so we know the path between this and this, right? So if user is standing here, which is neither A nor D, and it is requesting for something like this point in S3, and in S3 also we have a point E here, and then exit point this, maybe call it EX, right? Then how to go there? Then what we will do is, first we will find out what is the nearest point, basically on this edge, whichever is the nearest point. For this guy, maybe D is the nearest point, right? So and because if you have to go in this direction, so if D is the nearest point, from D to exit point EX, we know the route from our, which is already stored in our, which should be already stored in our database. From here to from this point to D, we will calculate the distance on the runtime, that this is only 0.5 kilometer, right? So this we can calculate. Same for this one. If basically we have to go here, so from exit point to this, how much is the distance? We calculate, maybe this is 2 kilometers, right? So this additional thing we can calculate on the fly, and we'll return the response as such. So from here to here, we receive the response from DB, and this one we will show in the end, because this is might not be this might be the only option, might be there are not even options. So from this point to this point, this is only one road, right? So that way you have to go from here only, right? So we will be able to serve to you that what is even for the points which are on the edges and which are not the real point which we consider, we will be able to handle those scenarios also. Okay, now going back, we just discussed this, what we didn't. Okay, now so now let's, here I only you know, said that I already have you know, from segment 1000 to segment 198, this will be the time, and these are the kilometers, and this is the route. I basically returning that, but the issue is still is that it might not have I will not say that it might not have. Now we need to think of how we will utilize that, you know, the information which we are getting from our users and third party data providers about live traffic, and also basically about road conditions and other inputs, how we utilize that to update our database, right? How we can do that. So it's the same design which we already have seen. Here I added another thing which is, you know, a streaming, think of a streaming service, Spark streaming, right? We can use Apache Spark or something else, but this is the most famous one. So I didn't add it earlier, I just added it here now. So what this will do is, when you are receiving the live data continuously, what you will do is you will send that live data to your Spark streaming. Same, so that you can, on your streaming, you can do, think of you are running machine learning, your models, yeah, right, your algorithms, which will ultimately keep on keep on calculating that for these points, maybe A to B, which we already have into our DB, the time is actually something, the time is actually 45 minutes as of now, right? So this guy will keep on processing that data, and it will keep pumping that data to our graph processing service. In case graph processing service is having a different, you can say different data for A to B, this guy will basically update that. So using these two inputs, basically Spark streaming services will process the data, and ultimately it will pump that back to one of, you can say, your on Kafka, let's say you have another topic for this particular thing, so it will pump the data to that topic, and ultimately this is my subscriber, so it will read the data and it will update my database. Okay, so that way it will keep on storing, updating on basis of your live traffic and data from third-party data provider. Here we might also think of that maybe sometimes the data from data providers is not that accurate, right? So those also we have to think of. So in combination of this live data and data which is coming from here, we will keep checking that maybe my provider says that, you know, it will take 45 minutes because of whatever road condition is bad or something, but in my live data where users are actually using Navigator, they are basically taking only 30 minutes. So my average time which is coming is 30 minutes for different users. Then what I will do is, obviously first is I will update that it is not 45 minutes, it is 30 minutes. And second is I will, you can say, flag that third party data provider also, that the data from you is not very accurate. And then I will basically take different actions, that whether I should rely on that third party or not, or maybe I will ask them to basically upgrade their service, better their service. Okay, I think that's it about the normal functional requirement. One thing which I haven't touched, and I think which I should talk about, which is not visible here, is because I'm talking about continuous feed from my server to my client, right? Especially in scenario of a navigator, I will not send multiple, continuous requests from my user to my server. What I will do is, ultimately there will be WebSocket servers, right? And users are connected to, this is like live connection between my user and my server. So users are connected to basically servers, and that is how they are continuously getting the data from server to client. Okay, and I think we already discussed in WhatsApp design or in Uber also, that how to manage WebSocket connections and how to have a WebSocket manager. So that is why I didn't went in deep of that, but think of that this is a live connection between a user and a server. So it is not like I'm continuously getting requests to to get further navigation from that point to the destination. So I think that's it. This is what I wanted to share in this one, and see you in the next design. Thank you very much.